All right, this is a continuation of the unit circle, and I just want to highlight a couple things on this slide. One, the unit circle has a radius of 1 and an equation of x squared plus y squared equals 1. And then the word trigonometry means the measure of triangles. Feel free to pause and read this slide if you'd like to. We're going to focus on the 6 trig functions. So on the left-hand column is the full name of the 6 trig functions, and then the right-hand side of those are the abbreviations. So on the unit circle, there is a set of ordered pairs. And then those ordered pairs respond to the sine, cosine, and tangent values, and then the cosecant, secant, and cotangent values. So we call the ones on the left, nicknamed the big 3, and the ones on the right, the inverses of the big 3. So the ordered pair for x and y, notice this will be your y value. So then the cosecant will be the reciprocal of y. For the cosine value, it's the x. And then the secant value, it's 1 over x. And then for tangent, you're going to divide by y over x. And then cotangent, you're going to reciprocate. The domain and range for the sine and cosine function are in this yellow box. So the domain of the sine and cosine function is all real numbers, and the range is from -1 to 1. So then you can see the graph of the unit circle on the coordinate plane. Here's your range of values between -1 to 1, and then the x values, any number can work. So we're going to go ahead and do this first example. And we have an ordered pair given to us. So I've graphed that out on our PDF. And we want to find the 6 trig values. So just so you know, to this angle is 120 degrees on the unit circle, or 2 pi over 3. So let's go ahead and find the 6 trig functions. So to find the sine of that angle, it is your y. So your y value is the square root of 3 over 2. For the cosine, it's your x value, so -1/2. For your tangent, you're going to take y divided by x. So I'm just going to go off to the side, y divided by x. You're going to have a fraction dividing another fraction. So we have to keep the square root of 3 over 2. We have to change 2 divided by -1. And then cancel the -2's. And then multiply across. Square root of 3 over 1 is the square root of 3. So those are the big 3. The other 3 are the inverses. So this is going to be 1 over y, 1 over x, and then x over y. So we're going to take the inverse of those. So we're going to have 2 over the square root of 3. We have to rationalize it. So we multiply by the numerator and the denominator by the square root of 3, and then multiply across. So we're going to get 2 square roots of 3 over 3. 1 over x. Reciprocate it. 2 over -1. And then reduce it. -2. Last one, x over y. Well, we already have this reduced answer, so we're just going to reciprocate that and then rationalize it. So we get the square root of 3 over 3. Here's another one. We give you an angle that is pi over 2. So here is the pi over 2 ordered pair, 0, 1. This is your x, and that's your y. So the sine of pi over 2 is your y. The cosine of pi over 2 is your x. And then the tangent of pi over 2 is y over x. So 1 over 0, which is undefined. Now let's do the inverses. So 1 over y. So 1 over 1 is 1. Secant, 1 over x. Well, 1 over 0 is undefined. Cotangent is x over y. 0 over 1, which is 0. So those are your 6 trig functions. Here's another example. Find the values of the 6 trig functions, giving the angle is pi over 4. So here is pi over 4, and this is your ordered pair. This is your x, and that's your y. So the sine of theta is y, square root of 2 over 2. Cosine is your x, square root of 2 over 2. Tangent is your y divided by your x, which is 1. Cosecant, we have to reciprocate. So we have 2 over the square root of 2. So I'm going to go off to the side here and simplify that. So 2 square roots of 2, we have to rationalize it. So we multiply the numerator and the denominator by the square root of 2. Multiply across, and then cancel. So we get square root of 2. Well, this will be the same answer below. And then cotangent will also be the same, because 1 divided by 1 is 1. We'll stop there.